A routine measurement is easy to ignore. At Haley Research Station in Antarctica, ozone readings were collected year after year. Numbers entered tables. Tables joined archives. The atmosphere seemed stable enough that most of those measurements attracted little attention at all. Then one reading arrived that looked wrong. Not slightly wrong. Wrong in a way that seemed unreasonable. The instrument responsible was a Dobson spectrophotometer, a machine built specifically to measure ozone high above the Earth. It was trusted. It had been trusted for years. Yet the value it reported suggested that something in the atmosphere above Antarctica had fallen far below what scientists believed possible. The easiest explanation was not that the atmosphere had changed. The easiest explanation was that the measurement had failed. The reading sat inside pages of otherwise ordinary records like a crack in a window. Everything around it looked normal. Only one number seemed impossible. And impossible numbers are often discarded before they are believed. The instrument remained in place. Antarctic winds continued crossing the ice. Sunlight disappeared during winter and slowly returned in spring. The machine kept measuring. The atmosphere, according to accepted understanding, should not have been capable of producing such extreme ozone losses. The reading contradicted expectations so completely that suspicion naturally fell on the instrument rather than the sky. Scientists checked procedures. They examined calibration. They reviewed recording methods. A mistake somewhere in the process seemed more believable than a sudden collapse of a planetary protective layer. For a time, that explanation felt comfortable. The instrument was probably responsible. The anomaly could be filed away as an error waiting to be discovered. The story might have ended there. Then Antarctic spring returned. Fresh measurements arrived. The same collapse appeared again. Not in a new location, not under completely different conditions. In the same place. At the same time of year. The explanation that had seemed sufficient suddenly had work to do. If the instrument was malfunctioning, why was it malfunctioning in such a consistent way? The records grew longer. Rows of ozone measurements stretched backward through time. Each new season added another mark to the pattern. The anomaly was no longer a single strange observation. It was becoming a recurring event. Scientists still search for mistakes because mistakes were easier to accept than the alternative. Yet every return of the anomaly removed one more comfortable assumption. A broken instrument can produce nonsense. A broken instrument should not produce the same seasonal story again and again. The Dobson spectrophotometer remained where it had always been, quietly collecting observations that many people still struggled to believe. And the readings kept arriving. The atmosphere above Antarctica appeared to be losing something.
Despite the clear conditions,
not gradually, not subtly, dramatically. The pressure inside the story changed. At first, the challenge had been explaining one unbelievable measurement. Now the challenge was explaining why the unbelievable measurement refused to disappear. The anomaly was beginning to look systematic. That created a new problem. If the measurements were correct, existing understanding of the atmosphere was incomplete. A trusted explanation was weakening. The next blow came from somewhere else entirely. High above Earth, satellites were also observing ozone. These systems have been designed for a different purpose. They were independent witnesses. They had no reason to repeat the same mistake.
Confirm this reading. The blue
Yet when
signature is
researchers
consistent across
examined
all
broader observations of Antarctica, a familiar shape began to emerge. A vast blue region appeared across ozone maps. The image was startling, not because it introduced a new mystery, but because it echoed an old one.
reveals the dramatic thinning of the protective
The
ozone
same story that had been appearing in ground measurements was now visible from space.
December 14th.
The anomaly had acquired a second witness, then a third, then another. Independent observations started pointing toward the same conclusion. The atmosphere was not behaving the way scientists expected. The measurements were not isolated. They were connected. The temporary answer that had protected confidence for years finally began to collapse. If multiple systems reported the same disappearance, instrument error could no longer carry the weight of the explanation. Something real was happening above Antarctica. The question changed. No longer, why are the measurements wrong? Now it became, what is happening to the atmosphere? The blue region over Antarctica returned again and again. Each spring it appeared. Each spring it expanded. Each spring it transformed old assumptions into weaker ones. The disappearing element was ozone. Invisible to human eyes, ozone forms a protective layer high in the atmosphere. It absorbs harmful ultraviolet radiation from the sun before that radiation reaches Earth's surface. The measurements were showing that this shield was thinning dramatically over Antarctica during spring. What had looked like bad data was actually a visible environmental transformation unfolding on a planetary scale. Only then did the earlier records acquire a different meaning.
Yet they foretold
The impossible numbers had never been isolated mistakes. They had been early warnings. Warnings arriving before anyone possessed a satisfactory explanation. Warnings arriving before the mechanism was fully understood. Warnings arriving while trust in existing assumptions remained stronger than trust in the measurements themselves. As atmospheric chemistry was eventually unraveled and the cause of the depletion became clear, the image of the Antarctic ozone hole changed from anomaly to evidence. The blue region on those maps was no longer a puzzle. It was a signal. Recognition spread beyond research stations and scientific journals. International agreements followed. Global action emerged from observations that had once struggled to earn belief. Yet the most revealing part of the story remained at the beginning. A trusted machine produced results that appeared too extreme to accept. People doubted the warning because it contradicted what they thought they knew.
Data from multiple satellites confirms the
And that may be the most unsettling detail of all. The first sign of one of the most significant environmental discoveries of the 20th century did not arrive hidden or invisible. It arrived measured, recorded, written into tables, waiting. The ozone hole was not discovered when the warning appeared. It was discovered when enough explanations failed that the warning could no longer be dismissed. And that impossible reading, sitting among ordinary numbers in an Antarctic record book, means something very different now. The measurement was never the problem. The measurement was the warning.